Hello, it's another scientific mini video. Today, we're gonna walk into the world of chemistry. But what chemistry? In this a bit quite brief video, we are going to talk about the atomic structure. There are three things we're going to talk about in this video. One, the electron configuration, and you all might know this, you might not. Secondly, the quantum numbers, and the last will be the isotopes. These three things are like concepts about the atomic structure. It's sort of like subtopics. This, my viewers, is the structure of an atom. Here you get the protons and neutrons. So in the middle part here is the protons and neutrons, and there are also electrons, and these electrons are located in these glowy rings. They are called the orbitals, and inside here you have the protons and neutrons, right? As I told you before, you have protons and neutrons. There's also a few things that you should know from above, from here. If you change the protons, it affects the identity, and it will result you in a different atom. And if you change the electrons, you change the charge. You change the charge, and then the result would be a different ion. And if you change the neutrons, it will affect the mass number, and definitely it will result in a different isotope. We'll talk about this later on in this video. Hey guys, right now we're gonna talk about quantum numbers. So let's start. There are actually 4 things you should really know about doing quantum numbers. Here, these are the 4 things. You get N, L, ML, and MS. You probably might be confused, but let me explain to you one by one what are they. N is actually the main energy level. So for example, we have 5p5, and usually you get this sort of questions. For example, find the quantum number of 5p5. So just by seeing it like this, we only get 5. 5 is the answer. So it's just extracting this to your answer. So there, we already have N equals to 5. So 5 is the main energy level. So for example, we have 6p2. The same still occurs. So N would be 6. Yep, that's how you do it. And secondly, now let's talk about the L. The L, there are 4 things you should really know about the L. There's this table that really shows you what a representative of that L is. So S, P, D, and F, right? We have 0, 1, 2, and 3. These are fixed. You can't really change them. So you really need to remember this because this is very important. Now let's say L. Let's think of an equation to do. Let's say 4d10. Right, so we need to find the L and the N. The N would be 4. The L would be this one. Sorry, we'll change that to another color. The L would be D. That would be D. And here in the D, you got 2. So L would be 2. Alright guys, since we've already discussed about how to get the N and the L, we're gonna go into the ML part of this topic. Now the ML. So we still use this electronic configuration, right? We still use this. We're gonna be using this a lot. Again, there's going to be a table which consists of S, P, D, and F. We have these things, we call them, well, boxes, but they're actually orbitals. They can hold only a maximum of 2 electrons in one box like this. And so let me tell you this: S has 1 box, P has 3 boxes, and D has 5 boxes, and F have 7 boxes. They only can contain 2 electrons. Okay, so we know that S is 1, so let's use this as an example. Okay, let's use 4s2, so let's not waste time. So for 4s2, wait, let me choose another color. For s2, we have N equals to 4, L equals to let's say SP, that's L is 0, ML would be, remember this, you should really know that these boxes have like numbers in them. This is 0, right? In S it would be 0 in the first box. In the middle of P there are 3 boxes, right? So in the middle would be the second one. The second one would be 0, and the center of these 5 boxes is the third box, and this would be 0, and 1, 2, 3, 4. Now this is the mid part of these 7 boxes, which makes him the 0. So what it means by 0 is just that to show later on in this video, to tell you the ML value. So for ML, it's not gonna be like just 1, 2, 3. There's going to be minuses. Okay, since we have this, right, and then we have this thing right here, those are the electrons that can fit in these boxes, right? Remember that these one boxes can only contain 2 electrons. So for this one, we have 1 up and 1 down. So that's 1 electron, and that's another electron, which makes it, which fulfills this. So ML would be 0. And then, but the funny thing is, we can also find MS. The MS is the last electron to go in. Is it the positive or is it the negative? The upper part, the ones that points like this, is the positive. And if it's positive, you put in positive half. So this is the last electron to go in. Is this electron pointing up? So that would be plus half. Let's try a different kind of problem. Okay, remember this is the middle box, the mid box of all of the boxes given in the formula, right? Should be 0. 6F9, right? So 6F9. So you change this to 6F9. Okay, so we have right now we have 6F9. So N would be, let's go here. N would be 6, and L would be, remember that F, what was F? If you guys remember, F is 3 for L, and for ML we can find it from this box, these boxes here, because these are the ones you should really be focusing, because this is the F, and it says here, it says F. so we should be really focusing here. Remember, there are 9 electrons. First of all, you should really input the ones pointing up first. So there's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the ML would be -2. So we have the number of boxes here, right? -3, -2, -1, 0, 1, 2, 3. So the last electron we just counted that was in -2. So ML would be -2, and MS is actually the electron spin which is pointing down, which is when it's pointing down it's actually -1.5. So the answer is -1.5. And try playing the video. And remember, we really need to remember the SPDFs. Right? Remember the SPDFs for L. Sorry, let me change that. For L, ML, and that is the only two that you should not be confused about. ML is the boxes, these boxes here. Remember that MLI boxes, and L is actually just from the table that says 0, 1, 2, 3. Yeah. So that's it. And MS has only have 2 values, negative and positive half. It really depends on the electron going in, right? So, hey guys, this is the mnemonic device that you will use to find the electron configuration. So you're probably confused, so I'm going to take this one out first. So 1 is the energy level, and S is the, or 2 is the number of electrons. Number of electrons that can fit into this orbital, right? It's like that. So let's take another example, 2p6. So the energy level is 2, and the orbital is P, and last is the number of electrons, which is 6, that can be put into orbital P. So let's make an example. Chlorine has 17, right? So 17 is, that's 1s2. Let's count how many that is first. 2 plus 2 is 4, 4 plus 6 is 10, 10 plus 2 is 12, 12 plus 6 is 18. 6, 18, so that's too much, right? So we need to minus. So we only need to have 3p5. That's it. So we now have the electronic configuration of chlorine. Okay, guys, I forgot to tell you on how to read the mnemonic device. So how you should read it, it's like this. First of all, you read 1s2, right, and then you read 2s2, and then read 2p6, and then 3s2, and then 3p6, and then 4s2, and then 3d10. It goes on like this. I know you're probably confused. It is very confusing for the first time, but here's how. Right now we're going to talk about the isotopes. Now, there's only a few things that you should know about isotopes. They're red. So this is the chemical element, and A is the mass number, and Z is the atomic number. Atomic number is usually equals to electrons, and protons are the same. And then there's the mass number. And let's see, if you change the proton number, you change the identity, and it will result you in a different atom. The electron, if you change the electron, it affects the charge, and it will result in a different ion. It will make an ion, and if you change the neutrons, it affects the mass, and if it affects the mass, you will affect the isotope. Note there's another one, about calculating the weight. So first of all, if you want to know the weight, you need to know the mass of the isotope, right? And then you need to know the percentage abundance. The percentage abundance is actually how often a particular isotope occurs in a sample of an element. So this is the formula to find the weight. This is the mass of the isotope, right? That is the mass. And then you have the percentage abundance over 100. So for example, let's make one here. 234U is 0.01, right? 0.01%. Now, so let's find the weight. So that's gonna be the mass, that is 234 times 0.01, which is the percentage, over 100.